Okay, and here we are in the tangent, the inverse tangent tutorial. Now, I already expect that you've seen the sine and the cosine tutorial, so please go back and watch those if you have not already done so. This will move just as fast as the cosine probably, since it's very similar. We're going to look at the tangent function first, so let's mark our axes, pi and 2 pi. Let's go out here to negative pi. Let's make our 1 and our negative 1. Now, the tangent has asymptotes. I'm going to graph those in. I know that the asymptotes are at pi over 2 and negative pi over 2. And then we play the little cut in half game. Cut in half, and that's our 0. Cut the top half in half, and there's our 1. Cut the bottom half in half, and there's our negative 1. And that's enough to figure out that the tangent function looks like that. Okay, we can continue this pattern over and over again. The asymptotes keep occurring every pi units, so every fourth tick mark is going to be another one. And over here. And then I can keep cutting things in half and doing this bunch of tangent graphs here. Actually, it's just one tangent graph. It's a bunch of periods of the tangent graph. Okay, so there's our tangent function. And again, this is not a one-to-one function because look at that, whoosh, fails the horizontal line test infinite amount of times. But we can take this single piece, and that's what mathematicians decided, this single piece right in here. We like this piece of the tangent function to talk about inverse tangent because this piece is one-to-one. Therefore, its inverse will be a function. Symbols, almost identical, except it's a tan, of course. So there's the inverse tangent, and here's the arctangent. And these symbols mean the same exact thing. Y is representing the angle whose tangent is x. This is why I'd like for you to memorize many of your tangent values so that you can answer some of these questions a whole lot easier. Let's look at our unit circle. We're talking about all the values in between negative pi over 2 and positive pi over 2. Notice that there are open dots on each of the endpoints because that's where asymptotes occur. So that's where inverse tangent, it looks almost identical to inverse sine, except that inverse sine includes the negative pi over 2 value and positive pi over 2 value, but not the inverse tangent. Inverse tangent is strictly in between. There's no equal to negative pi over 2 and positive pi over 2 because tangent does not exist at negative pi over 2 and at positive pi over 2. So please watch out for those two things. These are not equal to's, strictly in the middle. Okay, so inverse sine looks just like this, except it has the endpoints. Inverse tangent obviously looks like this, and the inverse cosine is the top half of the unit circle. So those are the three little bubbles of possible answers. Let's look at inverse tangent. Inverse tangent of 0. So for inverse tangent, it might help us to realize that the tangent is the same thing as the sine over the cosine. Because if I want to know when is the tangent equal to 0, that's the same thing as asking when is sine over cosine equal to 0. And this would be equal to 0 when the sine is equal to 0. It really doesn't matter what the cosine is because fractions are equal to 0 when the numerator is equal to 0. So this is another way of asking that. So if I'm looking for when the tangent is equal to 0, that's the same thing as asking when is the sine equal to 0. And when is the sine equal to 0? The sine is equal to 0 here and here. So that must be when the tangent is equal to 0. Look on your unit circle, the y-coordinates of each of these 2 points is 0. This one is ruled out because of course that's not in the inverse tangent little bubble here. That's got to be this one, which is 0 pi. I'm going to say 0 pi. Of course the answer technically is just 0. I like to say 0 pi to remind myself that I'm talking about an angle. So 0 pi is my answer. arctangent of negative 8.45. Now, negative 8.45 is definitely not a number that I recall from the unit circle. Now, some of you might be saying, because we looked at it in the other tutorials, that this is going to be something that does not exist. But that is not true. If we go back and look at the graph of the tangent function, the graph of the tangent function does not have a bounded range. Every single value from negative infinity all the way to positive infinity can be possible values, including negative 8.45, wherever that is. Okay, so negative 8.45 does not mean that it's going to not exist. What it means is we're going to need our calculator, because this is the only value that we're going to see in these tutorials where we cannot do this using our unit circle. So when I type in arctangent, first of all, I can't type in arctangent. I use inverse tangent, and the inverse tangent is above the tangent button in blue. Now, all of our angles so far have been in radians, so it's important to make sure that your calculator is in radian mode. Push mode and make sure you're in radian, or that you see it right up here. Then I'm going to go to inverse tangent, and I'm going to type in the negative 8.45. I'm going to close my parenthesis. Inverse tangent of negative 8.45 gives me negative 1.453. We'll go to 3 decimal places. Negative 1.453. I'm going to put in my approximate, negative 1.453. That's in radians. You're not putting a pi because it's not multiplied by 3.1415. It's just that. So that's a calculator problem. Everything else we're going to be able to do by hand. Okay, and our final two. These are really, really simple if you've already learned the little trick that I've taught you about the unit circle with tangent values. When you see 1, 3, the square root of 3, that's just a single 3, you know that the angle must have been pi over 3. Finished. When you see 2 3's, the square root of 3 over 3, you know that that must have been pi over 6. Finished. These problems can be very complicated if you don't see that trick. If you see 1 3, then it's pi over 3. Or if you see the 1 3 and pi over 3, then you know the tangent is square root of 3 with 1 3. If you see 2 3's, 3 plus 3 is 6, and that's why I know that it must be pi over 6. The only thing that might change is I might give you the negative square root of 3 over 3. And if I gave you the negative square root of 3 over 3, well, then you say negative pi over 6. Simple. So please catch on to that trick. 1 3, 1 3, 2 3's, 6. Or 6, 2 3's. Depends on which direction you're going. That's the end of the tangent tutorial, the inverse tangent tutorial. And we have one more to do, a few extra problems. I'll see you in that tutorial.